Hello everyone, we are still discussing angular projection in terms of projectile motion, and we are now in the third video of this series where we will discuss the time of flight. Just to recap, in the first video of our angular projection series, we spoke about how angular projection is different from horizontal projection. In the last video, I showed why the path of an object in angular projection is parabolic. And now in this video, we will talk about the time of flight. So first, let's see what all information we will need to find the formula for the time of flight. So let me recap what this diagram is like. We drew this diagram in the first module, but let me recap what information I have here. Here I say that at the initial point, the object is thrown with an initial velocity u, and this initial velocity u I have resolved into two components, u cos theta along the x direction, u sin theta along the y direction, where theta of course is the angle of this velocity, initial velocity that it makes with the x direction. So let me recap some things that we have already discussed. We have already said that the velocity of the object along the x direction will not change because there is no force acting on the object along the x direction, and therefore you can see that the initial velocity along the x direction is u cos theta, and even here the velocity along the x direction is u cos theta. In fact, if you draw the velocity along the x direction at any point in the motion, it will always be u cos theta because it remains constant. On the other hand, the velocity along the y direction is u sin theta initially, and as you can see here, we have not drawn any vertical velocity, which means that this u sin theta is decreasing and this vertical velocity becomes 0 at the point of maximum height, and then it increases again. So let me summarize. Horizontal velocity u cos theta remains u cos theta always throughout the motion. Vertical velocity is initially u sin theta, reduces, becomes 0 at the point of maximum height and then increases again. That's why you can see that the only velocity at the point of maximum height is the horizontal velocity because the vertical velocity is 0. Now with this information, I will begin my derivation of time of flight. Now if I want to find out what is time of flight, first I want to see what exactly is the time of flight. Time of flight is nothing but the time for which the object remains in flight, that is in air. That means the time from the point of projection to the time it comes back on the ground. This is known as the time of flight. Now I am going to divide this time of flight into two parts. And the two parts will be nothing but the first part is from the initial projection to the maximum height, which I will call as the time of ascent, that is the time of going up, and therefore this I will call as T1. And the second part is the time it takes for the object to go from the highest height to the ground again, which I'll call as the time of descent, which is the time it takes to go down, and I will call this as T2. Now obviously then the time of flight is nothing but T1 plus T2. But the idea is that the motion is symmetric about the y-axis. What does symmetric mean? If I draw a line right in the middle, then I can see that the motion path on the left and the right looks exactly the same, and therefore I say that the motion, that is the path, is symmetric, and therefore T1 and T2 are same. So now I can say that the total time of flight, which is T, capital T, which we will call, is nothing but T1 plus T2, but each of them are the same, and therefore instead of writing T1 plus T2, I am going to write T plus T because both are same, because path is symmetrical, and therefore I get capital T is equal to 2 small t, where small t is the time taken either in this portion or this portion, and therefore I get the answer that small t is equal to capital T by 2. This simply means that the time taken to go from O to H is half the time it takes to go from O to B, or you can say the time it takes to go from H to B is half the time it takes to go from O to B. So that means each of these is half the total time. That's what we have found. Small t is equal to capital T by 2. Now finally I am going to use the kinematical equation for the y direction to get the equation for time of flight. Now this is very simple. Initially the velocity in the y direction was u sin theta. At the highest point the vertical velocity is 0, and I am going to use this information to find the time of flight. So we say that at the highest point h, the vertical component of the velocity of the object is 0. And using this information, I'm going to write down the kinematical equation. So we know the kinematical equation, that is, I'm going to use V is equal to U plus AT, but I'm going to use this for the y direction. Now you can see Uy is equal to U sine theta. That means this is the initial velocity along the y direction. So initial velocity along y direction is U sine theta. What is the acceleration? We know that along the y direction, the only force acting on the object is the force of gravity, and because the force of gravity is acting down while the object is trying to go up, what happens is that the velocity of the object goes on decreasing. So as the object goes up, its velocity decreases, and because the velocity is decreasing, we have a negative sign, that is its negative acceleration. And how much is it? It is g, because the force producing this acceleration is gravity. So Ay is minus g. Again, to repeat, the minus sign comes because the velocity of the object is decreasing as it goes from down to up. T is nothing but t by 2. It takes half of the total time to cover from 0 to this point h, and therefore t is t by 2. And finally, Vy is 0. And why is it 0? Because at this point there is no vertical velocity. Finally, I will put all these values in the kinematical equation V is equal to U plus AT. But here I am talking only about y direction, and therefore I have the y subscripts. When I put all these values, what happens is I am going to take that 0 from here. So Vy is 0. Uy is nothing but U sine theta plus A is minus G into T, and T is capital T by 2. And rearranging this formula gives me the final equation for the time of flight, that is 2U sine theta by G, where U is the initial velocity, theta is the angle that the object's velocity makes initially with the x direction, or in general you can say U sine theta is the initial velocity along the y direction, and you have 2U sine theta upon G. This completes our derivation for the time of flight. I hope you understood how we found the formula for the time of flight. Thank you for watching. So thank you for watching this video on our derivation of the time of flight formula. If you like our channel, please subscribe. The link is below. You can also buy your very own target book by clicking on the link on the left. Please keep watching our videos and stay tuned.